Hello guys, welcome to Learn Chemistry with Oyin, and today we're going to be talking about electrolysis, the factors affecting electrolysis. Now, students a whole lot of times struggle with this part of electrolysis. They are trying to understand why is an ion deposited at a particular electrode, or why is it deposited at the cathode or at the anode. What's the whole chemistry behind the deposit of ions in electrolysis? So I've decided to make this video and explain every single thing about the discharge of ions in electrodes under electrolysis. So first of all, what is electrolysis? We can define electrolysis as the process which involves the chemical composition of electrolyte when a current passes through it. So we have what we call an electrolyte. An electrolyte is a compound that conducts electricity and is dissociated in the process. Now, what makes this different from a conductor is that both a conductor and both an electrolyte, they conduct electricity. However, a conductor is usually an element. So let's say silver, let's say copper, sodium. These are singular elements. However, electrolyte has to do with compounds. So if electricity passes through an element, let's say sodium, how many ions is in sodium? Just one sodium ion. How many ions is in copper? Just one copper ion. How many ion is in when I'm talking about ion, I'm talking about this. So you don't hear this. This is also, I'm talking about this ion. So how many ions are in a single element? Just one, right? So there will be no dissociation. However, compound has at least two ions. That's binary compounds at least. So your compounds have at least two ions. So once electricity passes through an electrolyte, that electrolyte dissociates into its respective ions, and that's the whole chemistry behind your electrolysis. So once this happens, there are two types of electrolyte you'll be seeing in questions on the electrolysis. One is the molten compound or the aqueous solution. Now, what's the difference between these two? The molten compound is simply a solid compound that has been heated to liquid. So the state of a molten compound is in the liquid form. The aqueous solution is a compound that has been dissolved in water. Hence, for your molten compound, where that compound alone is being heated to liquid, you're going to be having the compounds, you're going to be having ions that are only associated to what the compound is made of. Let me explain you an example. If you have molten sodium chloride and this dissociates, you're going to have only two ions here, and that is the sodium and chlorine ion. However, if you have aqueous sodium chloride, you won't just have two ions, you're going to have four ions. So remember, you dissolve sodium chloride in water, right? So you're going to have sodium, chlorine, hydrogen, hydroxyl. Hydrogen and hydroxyl from water. Now, do you understand the difference? Molten has to do with a compound heated to a liquid. Aqueous has to do with a compound dissolved in a liquid. So for the molten, you're going to only have those ions that the compound is made up of. And for the aqueous, you're going to have the ions the compound is made up of and the solvent used in dissolving a compound. This is what makes the difference. So if you're asked for a molten compound, let's say molten sodium hydroxide, what will be discharged at the cathode? Sodium. Now remember that in electrolysis, we have what we call electrode, the positive electrode through which current enters and the negative electrode through which current leaves. And the positive electrode is known as the anode. So your positive electrode is what we call the anode, spelled this way. And then we have your negative electrode, is known as the cathode. So for your positive electrode, the anode, what comes here is your anions. And what are anions? Negative ions. So ions with negative charge. So for this sodium chloride now, if we have molten sodium chloride, remember molten has just the ions the compound is made up of. So what will be deposited at the anode? If current passes through an electrolyte, remember that the electrolyte is going to dissociate. is going to be decomposed and is going to dissociate into its respective ions. So once current passes through sodium chloride, it's going to dissociate into sodium and chlorine. So sodium is positively charged, chlorine is negatively charged. So since chlorine is negatively charged, what we're going to call it? An anion. Remember that anion are negatively charged ions, while cations are positively charged ions. So this negatively charged ion, which is anion, will be deposited at the anode. And this positively charged ion, which is the cation, will be deposited at the cathode. And that's the difference. You get? Now, but when we have four multiple ions, we now start talking about which will be preferentially discharged. So if I have aqueous sodium chloride, it means that I'm going to be having sodium, chlorine, hydrogen, and hydroxyl. So between this and this, both of them are cations. However, both of them cannot be discharged at the same time. So one has to be discharged while the other will remain in the solution. Chlorine and hydroxyl, both of them are anions. However, just one has to be discharged while the other would remain in the solution. So how do we know this? And this is where we have the position of ion in electrochemical series. So now I'm just going to give you the two electrochemical series we'll be using, the electropositivity series and the electronegativity series quickly. So here is your electropositivity and your electronegativity series. Now I have a mnemonic for this. KSC mazilt. How can man see God? So K is potassium, S sodium, C calcium, Maz, MAZ, zeroth. So when I'm talking about this, I'm talking about ZITL, zinc, iron, tin, lead, zinc, iron, tin, lead. Hydrogen, it's how can man see God? Hydrogen, copper, mercury, silver, and gold. So this is the electropositivity series, and this is the electronegativity series. So this is NO3, SO4, 2-, and then you have chlorine, bromine, iodine, and fluorine just in the halogens. Now, okay, you should also have OH here. I think that's missing. OH is missing. So this is your electropositivity series, and then this is your electronegativity series. So yeah, now it says position of ion in electrochemical series. How does the position of the ion in the electrochemical series affect what will be discharged? Now, if you're given a question and you're told aqueous, now remember that for we to start looking at the electropositivity or either the electronegativity series, that compound should be aqueous. Once it's molten, we have no business with this. We just know that that compound will dissociate. The positive ion will go to the cathode and the negative ion will go to the anode. But when we have an aqueous solution, an aqueous compound, then we start looking at our electropositivity and our electronegativity series. So where we have this, the elements below in your electropositivity series will be discharged in preference to the element above. That's to say that if I have aqueous sodium hydroxide or aqueous sodium chloride, this will dissociate into what? Sodium and chlorine. Remember, this is aqueous, right? So I'm going to have both hydrogen and hydroxyl. Sodium is here, hydrogen is here. So remember I said that the elements lower in the electrochemical series will be discharged in preference to the elements higher in the electrochemical series. So this hydrogen and sodium, which one is lower? Hydrogen is lower, hence it is going to be discharged in preference to sodium. So what's going to be discharged at the cathode? Remember that positive ions are discharged at the cathode, while negative ions are discharged at the anode. So what's going to be discharged at the cathode? Hydrogen ion. So in this chemical reaction for your cathode, for the electrolysis of aqueous sodium chloride, you're going to have hydrogen being discharged. Now come to the electronegativity series. Chlorine and OH, which one is lower? OH is lower compared to chlorine. So what is going to be discharged at the anode? So at the anode, you have that OH will be discharged. And this is all using the position of ion in the electrochemical series. However, This works fully when the electrode used. What are electrodes? These are pipes through which current passes or leaves the electrolytes. Now, if you are going to be using this, the electrode used must be inert electrode. So we have three inert electrodes using this. Platinum, we have carbon, which can also interchangeably called graphite. So platinum, carbon, or graphite. These are the three inert electrodes that we are likely going to be using, or that is used, and it's going to obey this law wholly. Because this electrode that I just mentioned, they do not react with the electrolyte. So let's talk about concentration of electrolyte. Now, concentration of electrolyte only affects anions. And not just anions, but anions involving halogen. So meaning that if you have sodium hydroxide here, concentration will not affect. Okay, so we're going to see more questions. So concentration of electrolyte is going to affect what? Anions. And anions having what? The halogen. So for these electrolysis of sodium chloride, will concentration affect this? Yes. Concentration is going to affect this because here chlorine is a halogen. So how does concentration affect the anion? Now for the cation, for the cathode, concentration of electrolyte does not affect the cathode. So in the electrolysis of sodium chloride, for concentration, what's going to be discharged at the cathode? Sodium. However, at the anode, because this involves a halogen, and then remember that you're going to have two anion here. You have chlorine and then you have, so you have chlorine and then you have OH minus. So on a normal, if you obey this rule, this should be discharged. However, because this has concentration, what's going to be discharged here is the chlorine and not your OH. So this is going to go against the position of ion in the electrochemical series. And again, like I said, this only works if the anion is a halogen. Now, that being said, we can go to the nature of electrode. So rather than having OH discharge, when this has to do with concentration, you're going to have the chlorine being discharged. So now to the nature of electrode. Like I told you, as an inert electrode follows the rule of position of ion in electrochemical series and concentration of electrolyte also. However, when the electrode has the ability to interact with the electrolyte, the whole game changes, and I'm going to be explaining that next.